Alright, so today we're going to be talking about learning target 8, which says I can use an exponential function to solve a real-world problem. Now remember that an exponential function follows this form. F of x, or y, equals a times b to the x power. Now a, remember, is the initial value, the starting amount, or that really is the y-intercept in the function. B is how much the pattern is growing or decaying. So we call that the growth or decay factor. And the x is the number of times that the situation is growing or decaying. So A is the initial value, B is the growth or decay factor, and X is the number of times the situation is growing or decaying. Now the growth factor and the decay factor work differently if you're dealing with a percent growth or a percent decay. Both of them are B, but a growth factor is going to make your function get bigger and bigger and bigger. And so if B is a growth factor, your exponential function is going to look like that because the value is getting bigger and bigger and bigger and bigger. If B is a decay factor, which makes your function get smaller and smaller and smaller, your function would look like that. It starts out big, but it gets smaller, 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 smaller. Now, for both of these, it involves if there's a percentage increase or a percentage decrease in your situation, you cannot just plug a percent into your equation as the b value. You have to first change it to a decimal. So if the function is growing or increasing, then b represents the growth factor. And if it is increasing by a percent, then we change the percent to a decimal and then add it to 1. If it's a decay factor, so the function is decreasing like this, then b represents a decay factor. And if it is decreasing by a percent, we have to change the percent to a decimal and then subtract it from 1. So let's look at these. So let's say that we have a situation where we have some amount that is increasing by 4%. The first thing we have to do is change this 4% to a decimal because we cannot just put a 4 into our equation as the b value. We have to change it to a decimal first. So remember, to change any number to a decimal, we move the decimal to the left 2 places, because it's like we are dividing it by 100 or multiplying it by 1/100th. Any of those ways will cause you to change a percent to a decimal. So if right now in a 4, whole number 4, my decimal is right there, right after the 4, that means that 4% as a decimal is 0.04. Because it was there, then it moved 2 spots to the left. I can fill in my little loop-de-doo with a 0 right there. So it turns into this. So my loop-de-doo with a 0, and then I get 0.04. Now, that's not my b value, though. That's just the percentage increase. And if it is increasing, that means I need to add it to 1. So I do 1 plus 0.04, which equals 1.04. That would be my b value. I change my percent to a decimal, and then I add it to 1 because it's increasing. If it's decreasing, I still need to change my percent to a decimal. So I can say, well, 2, that's where my decimal is in this whole number 2. If I want to change this this number to this percent to a decimal, I'm going to take the 2, move the decimal 2 spots to the left, So the percentage decrease is 0.02. And if it's decreasing, then to get my b value, I have to subtract it from 1. So 1 minus 0.02, which equals 0.98. Okay? This next one, so that would be my b value. This next one is decreasing by 10%. Here's where my decimal currently is, in the number 10. But if I want to change this percent to a decimal, I'm going to move my decimal 2 spots to the left. So now it's 0.10, or just 0.1. I don't need that 0 on the end. Same thing. And because it's decreasing, I'm going to subtract my decreasing factor from 1, which equals 0.9. So my b value is 0.9. Now, this one is increasing again. I still need to change the percent to a decimal. So I take this 20%, that's where my decimal currently is. And to change the percent to a decimal, you move the decimal place 2 spots to the left. So there. So it's 0.20, which is really just 0.2, either way. And because it's increasing, I'm going to add it to 1. If it's increasing, then I add it to 1. So 1 plus 0.2, which equals 1.2. So in this situation, this would be my b value, 1.2. Over here, it's decreasing, so I'm going to move my decimal 1, 2 places to the left. So it's 0.015. And because it's decreasing, I'm going to subtract it from 1. Decreasing is subtract. So 1 minus 0.015. And that equals 0.985. So in this situation, my b value would be 0.985. Here, I'm going to move my decimal 2 places to the left, so I end up with 0.032. And because it's increasing, I'm going to add it to 1, so I get 1 plus 0.032, which just equals 1.032. So in this situation, if it is increasing by 3.2%, this is what I would use as my b value. Here it's decreasing by 7%, so there's where my decimal is right now in the percent. So I'm going to change this percent to a decimal, so I go 2 places to the left, and I end up with 0.07. And because it's decreasing, I'm going to subtract it from 1, so 1 minus 0.07 ends up equaling 0.93. And then this last one is increasing by 0.2%. So there's where my decimal currently is. I'm going to move it 2 spots to the left, so I end up with 0.002. And because it's increasing, I'm going to add it to 1, so I get 1 plus 0.002. So my b value will be 1.002. So now that we're finding the b values, all you have to do is find the initial amount, because that is the value of a, and then you have all the information you need to write the function. Now remember that a is the initial value. So if we look at this example, it says a $17,540 car is depreciating, which means decreasing in value, at a rate of 12% per year. What is the value of the car after 8 years? Well, A is the initial amount, the starting value. So that is going to be 17,540. B is it is decreasing in value 12% per year. So just like up here, that means it's decreasing by 12%. So we're going to take this 12%, that's what the decimal is currently after the 2, move it to the left 2 spots, so it's 0.12. And because it's decreasing in value, we're going to subtract it from 1. Up here it says decreasing is subtract from 1. So we're going to say 1 minus 0.12, which equals 0.88. So our b value is 0.88. And that means that our function, if we have our a value and our b value, we would just plug them in here for a and b. So our overall function is f of x equals the a value times the b value to the x power. And that is it. That's our function. Now let's look at this one. It says the population of a town is currently 12,000 people. The population is increasing at a rate of 3.4% each year. What will the population be in the year 2025? Well, the value of A is the starting amount, which is 120,000. The value of B, we look at the percent of increase, which is 3.4%. So the first thing we're going to do is change that to a decimal. So it ends up being 0.034 as a decimal. And because it's increasing, we're going to add it to 1. So 1 plus 0.034, which equals 1.034. So that is our b value. And so the function is f of x equals 120,000 times 1.034 to the x power. So that's the function. And now that we have the function in each of these examples, we can answer the questions that they're asking about them. Now for this one it says, what is the value of the car after 8 years? Well, the x up here, this exponent, is the number of times the situation is growing or decaying. Well, down here it says that it decreases 12% per year. So after 8 years, it would decrease 12% 8 times because it does that each year. So for 8 years, that would be 8 times. So to find our answer, we are just going to see what this equals when we have an 8 up there for our exponent. So right now, go ahead and take your calculator and type this in and see if you get what I get. So here's my calculator that you cannot see yet. I'm going to make it a little bit darker so it's easier to see there. There it comes. Slowly coming. There, we can kind of see it better now. So to type that into your calculator, we're going to do 17,540. In parentheses, we're going to put 0.88. And then we're going to use this button right here, right below the control button. That's what gives us our exponent. So if we push that button, it creates a little box right there. Then we're going to fill that box with 8. Then hit enter. And this tells us that our car is going to be worth $6,307.99 after 8 years. For this one down here, if we look at this one, we're going to use our equation to figure out what the population will be in the year 2025. Well, it's currently the year 2016, so 2025 is 9 years from now. So if it increases this much each year, that means 9 years from now it will have increased 9 times. So we are going to figure out what this equals, the 9 up there, to get our answer, because the x is just however many times it's increasing. So Let's see what that is. We have 120,000 times 1.034. And then I'm going to, in the little box, so I'm going to use this little up arrow button right here to get that little box up there. And I'm going to fill that box with a 9 this time. Enter. And so that means that in 9 years, this town that started at 120,000 people will have 162,131 people altogether. And that is how we can use exponential functions in the real world.